Hi everyone. Hi. So I hope we can start with the tutorial. Uh, okay, so okay. So welcome everyone for this tutorial on face recognition using Python. I am Anil Sharma and I will be your tutor today. So let's just see what we will be learning today. So I have divided this tutorial in 5 sections. In the first section, we will see a small introduction to machine learning systems. And then in the second section, we will see an introduction to face recognition. And we will see a few examples of face recognition. And then in the next 2 sections, I will be talking about face detection and face recognition with the live coding. And I will show you some interesting examples by performing some operations on the real images. So for example, I will show you how to apply makeup on faces, how to like rotate faces, and a few interesting examples. And then in the fifth section, I will leave you with a take-home exercise in which you can develop your own home surveillance system using the face recognition technology that you will learn in this tutorial. I hope all of you will go and will try this on your own and will develop a home surveillance system that will automatically do face recognition and will identify who is coming at your home and who should not be coming at home. Okay, so before we proceed, I would like to suggest that you should have a basic programming experience in Python. And if you don't know Python, I would suggest you to refer this tutorial to start with Python. And the tools that we will be using in this lecture are Google Collaboratory, which is a Google Cloud platform to provide access to Python notebooks and GPUs. Alternatively, you can also use PyCharm, Jupyter Notebook, or you can also directly work in command line if you are comfortable with it. So for machine learning stuff, we will be using DLib machine learning library, or specifically we will be using machine learning face recognition package that is built over DLib, and it's available freely, and you can install it using this command pip install face recognition. The advantage of using face recognition as compared to DLib is that like it provides easy access to the face recognition functionality by simple functions. Okay, so let's just start with our first section in which I will provide a basic introduction to machine learning system so that we can proceed with developing our own face recognition system. Okay, so machine learning systems are basically follow this kind of architecture. Let's say if we have an input image, so let's say in this case it's a car. So we generally perform 2 steps. One is the feature extraction, another is classification. So in feature extraction, we write a script to identify the features of the input basically, like, we have to identify the unique features which will identify us to say that, okay, these features belong to a car. And then in the second step, using these features, we build a classifier. Generally, it is like in traditional machine learning, this is done by SVMs, KNNs, and but in recent days, like, we use neural networks to perform all kinds of tasks, and then this classifier returns whether the input category or the input features belongs to a car or it doesn't belong to a car. Okay, so let's just give some more examples. So let's just talk about classification, more particularly binary classification. So binary classification is a technique where we like classify a set of images into two classes. So for example, let's say consider cat versus dog classification, in which we classify some set of images into two categories, like whether these are dog or cat. So for example, like, let's say we are providing cat image to as the input to the machine learning system, and it will say that, okay, it belongs to a cat. If we give input of a dog's image, it will say that it's a dog. Another example is mask, no mask face classification, where the machine learning system will first say whether a particular image contains a face or it doesn't contain a face. And then if it contains a face, whether that face contains a mask or it doesn't contain a mask. Okay, so we will see a few more examples. So for example, face or no face classification, where like, we have to say whether an image contains a face or it doesn't contain the face. So there are many more examples for binary classification. So I just wanted to give an idea of classification, particularly binary classification, which we will be using in subsequent sections. Okay, so as I have also talked earlier, machine learning system is basically carried out in two steps. One is a feature extraction and another is classification. And this is a kind of system we have discussed. The features are an individual measurable property or characteristics of the input data. Okay, a classification is the process of categorizing that set of input data into classes or categories. Okay, so generally these classes are predefined if we are talking about classes. Okay, there are other kinds of techniques in machine learning if these categories are not known. Okay, so we will not be talking about that because we will not be using these in our face recognition tutorial. Okay, so in the modern days, we are using deep learning, which is a sub branch of machine learning, where we are using using neural networks to perform all the tasks. So for example, like in using deep learning, we don't have to write a script for feature extraction. We don't have to identify unique features of the input data. So it will automatically do that. So this neural network will automatically perform both the tasks. So for example, feature extraction and classification, and then it will directly say the output whether it belongs to a car or it doesn't belong to a car. So that means these recent techniques are very powerful because we don't have to do any hand engineering. We just have to provide the input data and then we can take the output. Okay, so and due to this advancement by the deep learning, this AI and machine learning techniques are very prominent in solving the real world tasks. So, and then we will see the examples using face recognition. Okay, so let's just move further. So, so this machine learning system is generally we carry out it in two stages. One is a training stage and another is a testing stage. In the training stage, what we do is we have lots of data. So we provide this data to the learning system, where the learning system performs the two tasks. What is a feature extraction and classification, let's say, and the classification will say the correct output. Okay, so this correct output is like the output of the machine learning is specified as correct or incorrect by the ground truth, which is already available in the input data. So that means in the training stage, the machine learning system is learning what is the right output of the input. And in the testing stage, what we are doing is we are using the learning done in the training stage, and we are providing new input data to the learning system, and it will provide best guess from its learning on to which category the new input data belongs to. So that means we are learning during the training phase, and we are using this learning during testing phase. So it's like how humans perform. So for example, like they learn during their training stage, and then they use their learning to perform in the real world. Okay, so why are we using machine learning and deep learning? So like I just want to interrupt the tutorial. Like if you have any question, please write in the comments. When the tutorial is over, I will take those comments, and then I will try to answer your questions. Okay, please feel free to like write your questions so that I can answer it at the end. Okay, so let's come back to the slide. Why are we using machine learning or deep learning for any real task, for example, face recognition? So it's because deep learning has led to huge advances in the performance, and in many cases we have seen human level performance and more than that. So the another reason is that like we have now access to the large amount of data. So for example, ImageNet dataset made breakthroughs in object detection. So that means we have like large amount of variations of that data, and the machine learning system can learn those variations. And another reason is the computing power that is available these days. So that means we have easy access to the GPUs and TPUs, and even Google has released a free access to the GPUs and TPUs through Google Colab. So that means people can start working with these technologies very easily without spending too much money. So for example, let's just see like Amazon, Facebook, Google, these tech giants have access to a large amount of data, and that's why we can say that. So for example, like Facebook has access to all our data that we upload on Facebook. So for example, our images, our face images, like places that where we are going, the kind of clothes that we wear. So it has access to everything that we are uploading. Okay, so that's why we can say that the systems are highly accurate for various tasks, whether it's object detection, whether it is place recognition, whether it is like 3D object classification or cloth classification, like that. So they are highly accurate. So this was a like small introduction to machine learning systems. I think this is enough to proceed with the with coding face recognition in Python, and we will be using this knowledge in our tutorial. Okay, so like that. So they are highly accurate. Okay. So now we will move to the second section where I will be talking about introduction to face recognition. So face recognition is the ability of a machine system to recognize a person face in the image. So that means we are teaching computers how to detect and recognize a face. So just see this example where we have a machine learning system and we are providing this person's image as an input to the system. The system will say where the face is like is there in the image. So for example, it has drawn a bounding box on the face, and then it will also say the identity of this face. So for example, here it is saying that this face belongs to John. Okay, so there is a like trivial difference between face detection and face recognition. So in the detection, we only care about identifying, like not identifying, only locating the faces in the image. So for example, if you see this left image, there are 5 faces, and the task of face detection is only to locate the faces in the image. And the face detection algorithm has correctly located 5 faces in the image. Whereas in face recognition, we perform much more than face detection. So for example, it not only performs face detection, it also identifies the identity of the face. So for example, here the machine learning system says that, okay, this is a face and this face belongs to Nicole. So that means it is also identifying the identity. And along with that, we can also do some more tasks. So for example, we can do age detection, we can do gender detection. So for example, here the system says that this face belongs to female who is 26 years of age. Okay, and we can, and then in the recent days, we can also perform emotion detection from the images. So that means here the system is saying that like this face is smiling, and the system's confidence is 96% in saying so. Okay, so let's just see a few applications of face recognition. Why are we doing face recognition and where can we use it? So one common application is in digital photography, where the recent smartphone cameras or the digital cameras that we have, they automatically perform face detection, so that we can automatically focus on the faces to get good quality images of the people. Okay, another important example is dynamic range enhancement. So for example, let's say if the background is too bright or too dark, how to adapt that like that range, the dynamic range, and to perform dynamic range enhancement. So if we can locate the faces in the image, so then we can do this automatically, so that we can focus more on the face as compared to the background. Okay. So one of the potential application of face recognition is in surveillance, where let's say we can deploy this system in a building where we have to like recognize who all are coming into the building. So for example, here the system is saying that, okay, these are the faces and this is the identity. If a non-identity comes in the building, so then the system can inform the security, and then they can take the take an action accordingly. So these days, teleeducation is highly popular due to the pandemic. So like even if it is not pandemic, if it is an offline or the physical classroom, we can perform face recognition to identify who all are attending the lecture. Or like if it is an online class, we can easily like do face recognition, whether the person is sitting in the in front of the camera, or like what kind of actions he is doing. After recognizing the face, we can say that, okay, whether he's actually accurately concentrating or not. So that means we can do some emotion recognition and can do much more in this. So this is highly popular. If you people find this tutorial very, you can develop such systems and you can sell these and make a business out of it. So there are many popular applications. So for example, album organization. So let's say if you have lots of images, you can organize these photos by persons, by recognizing persons. So if it's a person A, you can just say that, okay, I will put all the images of person in all the images of person B in another folder, and so on. Emotion and expression recognition that I have talked about a lot in this tutorial till this point. And another application is identifier of unique people, and this has lots of applications in marketing. So for example, let's say if I have a stall, and if I can recognize, okay, this is the person who has come for the first time, then I can do the marketing very effectively to that new person. As person is returning, then I can do the marketing in a different way. Okay, so this is how we can do the marketing and face recognition in this. So there are many more applications. I have just listed only these 6 applications. Okay, so the tools that are available for face recognition are both commercial and open source. So the commercial source are basically they require sharing your data with the cloud. So that means we are using a cloud service, maybe from Amazon, from Facebook, and what we have to do is we have to upload our data to the cloud. The computation will perform on the cloud, and then we'll get the results from the cloud. Okay, so it requires an active internet connection. So I'm not sure if I'm too fast. Please like comment it. I'm seeing your comments. If I'm too fast, please like comment that like I'm too fast. I will try to slow down. Okay, so the popular commercial face recognition tools that are available are, first of all, like very famous is recognition API, where like it provides functionalities like face recognition, emotion detection, and motion tracking from the images. Another is Microsoft Azure Face API, where we can do face recognition, age and gender detection, and face similarity. So face similarity is basically a very interesting application where we can upload our face image and we can identify who is the most similar face to our face on the internet. Okay, so there are many open source tools are also available, which can run offline, which will use the resources of your device, and you don't have to share your data with any cloud. Okay, so one popular is OpenFace, another is DLeap that we will be using in this library in this tutorial, and the face recognition package which is built by Adam Gitge, which is available here. We will be using this package to perform face recognition in this tutorial. Yeah, so this is what I had in the first two sections. Maybe we will proceed with the third section, which is about face detection, and then we will talk about face recognition, and we will see some live examples to code in Python. So let's just proceed with face detection. So face detection is just the ability to detect and locate faces in the image. So that means we are teaching a computer whether an image contains a face or it doesn't contain a face. Okay, so for example, in this image, we have a machine learning system. We are giving an input face image to the system, and then the system is saying whether this image contains a face or not. So that means the output will be yes, it's a face, or it doesn't. It's not a face. Okay, so before proceeding with the actual face detection, I would like to say something about sliding window classifier. Many of you might be aware about it, but let's just say about it. So let's say if we have a very big image. Earlier in the images that we have seen, the images were small and it was very obvious to say, okay, it has a face. But like in real world, we will be having big images. So what we will be doing is we will be using a sliding window classifier where we pick a window first, and then we slide this window over the whole image, and we will say whether a particular window has a face or not. Okay, so let's say we will, for all the windows, we will be running our face detector, and the face detector will say, okay, if it's not a face, we will skip this window and then we will move to the next window. If a particular window says that, okay, yes, it's a face, we will stop there, and we will the system will output that, okay, this is the face, and then we will keep moving the window over the whole image to identify more faces. Okay, so the common face detector algorithms that are available are three commonly used. Like for one of the most commonly used face detection algorithm is Euler-Jones, traditional machine learning based approach, and it was used like a few years back, and was used actively and rigorously in many of the applications. So it's a decision tree based algorithm, and which is very fast. It was designed for low resource devices, so that like you can run it on your mobile phones or like single computers. So the disadvantage of this approach is that it has large false positives. Okay, so that means these are like not that accurate. So after that, like we had feature based detectors. So for example, we could have used HOG based features. HOG is histogram of oriented gradients, which we will be seeing in the next slide. And then like basically histogram of oriented gradients is nothing but we are computing a histogram of the gradients, which are the information, like the change in the information from light to dark regions. We will see like what it actually means. Okay. And then it is slower than Euler-Jones, but it is accurate. It has low false positive rate. And there are other feature-based approaches are like Haar cascade approach, which we can also use. The most popular these days is neural network based, in which we are using convolution neural networks to extract the features from the faces, and it is highly accurate. It is highly accurate. So this is the only thing that we are using these days. These Euler-Jones and feature-based have gone old, and the new basically like the new and the most popular technique is this convolution neural network based. The only disadvantage is that like they need very large amount of data and sophisticated hardware for training. Okay, so for example, if you have GPUs, we can train it easily. If we are training it on CPUs, then this is highly slow. and it won't be able to, you won't be able to train on a like resource constrained device, for example Raspberry Pi. So generally what we do is we train it on a laptop, and then we port the system on the low resource device, and we only perform inference there, we don't perform any training. Okay, so this was like some introduction about face detection. Let's just see what is HOG, like which stands for histogram of oriented gradients. These are nothing but like this provide counts of the, so that means counts occurrences of histogram or so gradient orientations in an image. So so what is a gradient orientation? So like in the image we divide the image into different cells. For each cell in the image we compute the gradient. The gradient is nothing but the change in the pixel value from light to dark region or dark to light region. So for example, for each cell, and then after computing the gradient, we compute the histogram of these gradient values. So gradient is nothing but a value which is coming from subtracting the pixel values from light to dark regions. So let's just see. So let's say this is the small part of the image that we have seen in one of the previous slide. Okay, here each square is a pixel. So this is a very small image. I have just zoomed in so that you can see each pixel very clearly. So we can see that okay, there are a few dark pixels, there are a few light pixels, and I have highlighted a pixel like in blue. Okay, so let's just say we compute the gradient value at that particular pixel. So what we will be doing is we will be taking all the neighboring pixels of that particular pixel, and then we will be computing the difference between the left pixel and the right pixel. Okay, and like we will also compute bottom pixel and the top pixel. So we will basically compute difference between all pixels, and then we will identify which is the most like prominent direction here. So that means which difference, left to right or top to bottom, which difference is higher. So in this case the left to right difference is higher. So that means we can say that the gradient is like 180 degree, we can say. So that means it is going from left to right. So in general, this is I have taken only 4 neighbors here, but we can take 8 neighbors. Okay, so for example, let's just see this case. So this is the whole image. For illustration, we have divided it into different cells. Okay, and then we have computed the gradient for each cell. Okay, so basically the gradient is in different directions. So it is in the left to right, it's from bottom to top, it's from like bottom left to top right, like that. Okay, and then we'll take different blocks in this image, and then for each block we will be computing histogram, and then like, so basically these histograms are the key point descriptors. So let's just see an example. Okay, so let's say this is our image, input image that we have seen, we have also seen in the previous slide. So this is the output of the histogram of oriented gradients. Just see that, like, so the color information from the background has gone away. Okay, so but the features of the face, for example, eyes, nose, lips, and the chin structure, right? So this is intact. So that means histogram of oriented gradients are very good at capturing features of the face. Okay, so this is the output of this image. So here what we are saying is like which kind of orientations has the most number of pixels. So that means like 100 to 120 orientation has the like largest number of pixels. Okay, so this will be clear in the code that I will be showing. Okay, so I think I will be talking about it in detail in the code. Okay, so let's just see how to perform face detection using HOG features. Okay, so like the steps that we will be performing is, the first step is that we have to collect a lot of training data and we have to extract HOG faces. So as we have seen in the previous slide. Okay, so that means we will collect images, like, so for example, this is one of the image which doesn't contain a face. This doesn't contain a face. This contains a face. This doesn't contain a face. Doesn't contain a face. It contains a face. So I've shown a very few examples, but like in reality we collect a lot of data whether of the images which contains face, which doesn't contain a face. Okay, and then in the second step, what we do is we train a face classifier on these HOG faces. So that means we are training a machine learning system. Okay, and then we will be using our sliding window classifier to locate faces in the image. Okay, so this is how we will be using it. So that means, like, let's say from the sliding window, if this is a window in the image, so we will first, what we will be doing is we will extract HOG features, and then we will use our machine learning system, and the machine learning system says that, okay, it contains a face. Similarly, if the image doesn't contain a face, the machine learning system should say that it doesn't contain a face. So in this tutorial, we will be using a pre-trained model from the face recognition package, and that means we will not train any of our model, so that we can easily perform face detection without worrying about training a new model. Okay, so I will show you how we'll be doing it. Okay, so the advantages of HOG features are that they capture enough detail of face, as we have seen in one of the previous slides. Okay, so these are not affected by small changes in lighting, and these also are not affected by small changes in the object shape. Okay, so that means these are very robust kind of features, and these are fast and easy to compute even on a resource constrained device. Like if there are a large number of variations in the face. So for example, if face is rotated or like occluded, these features may not perform well. But like, let's just we will be using a system from these HOG features, and then let's see whether we can perform face detection or not. Okay, so now we will proceed with the code example. Just give me a few seconds to open the Colab. Okay, so okay, so this is our code example. Okay, so here, this is the Python notebook provided by Google, and we can easily access it in. Okay, let me just change. Okay, its runtime is GPU. Let me just mount my Google Drive. Okay, it generally takes time, so it will take a few more seconds. So it will give us a URL, and we have to click on this URL, and then we can proceed with it. Okay, so I have copied it, and I will paste it here, and then it will take a few more seconds to mount it. Okay, so now we will mount this directory. Okay, we'll change our working directory, and then we'll go with everything. Okay. Okay, your screen was not visible. I have just added it to the stream. Sorry for it. So I hope you can see it now. Yeah, sorry for it. My bad. I think now you can see the screen. Yeah, so Basically, what I have done is I have just mounted my Google Drive. I have changed my working directory and I have installed face recognition package. This is what I have done. Okay, so now we will see HOG features. So, like what I have done is I have will be using matplotlib to to show images and to perform some operations on the images. So, like we will be using it. We will be using SK image to compute our HOG features, and we will be using OpenCV. So basically, import CV2 is for OpenCV, which I will be using for reading images. Okay, so using cv2.imread, we can I hope my code is visible on the screen. Okay, I hope, yeah, it's visible. Okay, so cv2.imread we will be using to read the images, and then we will be using cv2.convert color. So basically, OpenCV reads the images in BGR format. So we'll be converting it from BGR to RGB using this CVT color function. So I have read this clone1 image clone1.jpg, and then we will be using this HOG function from SK image to compute our HOG features. So basically, what we will be doing is we will providing the input image, the number of orientations. So that means the neighboring pixels are 8. The pixels per cell. So this is the window size, and this is the block size that we have seen in the slides, and other are self-explanatory. So what we will be doing is we will. So this function returns two values. So one is the feature descriptor, which is a histogram, and then one is the HOG image, which will show that like how your image is transformed as a HOG image from the input image. So let us see how the output looks like. Okay, so then I have plotted the input image and the HOG image here. So this is our input image, and this is the HOG image that we have also seen in the slides. Okay, so you people want me to magnify my screen. Let me just magnify it. So just wait for a few seconds. Maybe I think instead of magnify, I will be. Is it visible now? Okay, so I hope it is visible now in a great detail. Okay, so the advantage of this feature descriptor is that our input image, let's just say what's the size of the input image. Okay, so it is like 530 cross 941 cross 3. Okay, so which is a very large number. So it is around 10 to the power 4, 45, 10 to the power 5. It's around 1 million. Like these pixel values are 1 million. If we see the feature descriptors that we have are only 15,000. Okay, so that means like we have a very small value for the input image which captures our face. So let's just see one more example. Maybe let's just see Leonardo. Okay, so let's just see how it works. Okay, so that means like yes, these HOG features accurately capture the what we say the face structure, and we can see it from the images. So now let's just perform the face detection. How to perform the face detection? We will first import the face recognition package. Okay, and then we will be using matplotlib to plot to show the images, and we will be using rectangle and circle from matplotlib to plot rectangles on the faces, and again CV2 for like reading images. We have written matplotlib inline because we are using a Python notebook, and we are running it in a browser, so which doesn't allow pop-up. So we will be running everything inline. So that's why this line is very important. Okay, so to perform face detection, we will first read the image. Let's just say read a single person first, maybe clone one we can read. and we will be doing convert color. Let us convert the images. Okay, so this is the image. I think this is the only image that we are using. So what we will be doing is we will be using this face recognition, and then this face recognition provides a method called face locations. So that means we don't have to train a machine learning system. It will automatically use a retain model, and it will return the location of the faces. Okay, so it will return the location of the faces. So basically, if there are multiple faces in the image, it will return multiple locations. So let's just see how many face locations it has returned. Okay. Okay, it says an error. Why? Okay, face recognition is not defined. Okay, we did not import face recognition. Sorry for it. Okay, now it's imported, and now we can run it. It says one face in the input image, and just let us show like where is the detected face. So to do that, what we have done is we have shown the image first, and we have got access to the axis handle in AX, and then we will be plotting a rectangle above the face. So what we will be doing is so there could be multiple face locations written by the face location function. So so for that, like we will be running a for loop for all the faces. Okay, even if it's one face, it will work. So so for each face location, like the face locations are in this format: top right, bottom left. So we have just converted it into a rectangle, which is xy, which is the top left corner, and the width of the rectangle and the height of the rectangle. We will be using rectangle function to what we say, to plot a rectangle on the image. Okay, so let's just see how it will look like. Okay, so this is the location. Okay, so let's just read one other image. Maybe this time something else. Maybe a woman image. Do we have a woman image? Yeah, we have a woman image, and then let's just see how it will do. Okay, so this is the woman, and let's just do the face direction. Okay, it says one face, and then let's just plot it where the face is. Okay, so this is the location of the face. So this, just see that like this face is slightly rotated towards right, but still the face detection is very accurate. Okay, so just try to do it in the multiple faces, whether it works on multiple faces or not. Okay, so I have a, let me just see. Okay, we have this image where we have two faces. Okay, so which has Cloney and Leonardo, and so it says that there are two faces in the image, and then it should be able to plot. Yes, it is plotting a rectangle at both the faces. So that means this face detection is very accurate, and we can use it to do face detection. Okay, so this was a small coding tutorial for face detection. So now we will see how to perform face recognition. That means after detection, whose face is this? How to teach the computer that this face belongs to Cloney and this face belongs to Leonardo. Okay, basically the first one is Leonardo, second one is Cloney. So we will see how to do that. Okay, so let me just first share the screen. Okay, so this is okay. Yeah. So I hope you can see my screen. Which is taking time for some reason. Okay, now we will go to face recognition. Okay, so we'll see how to perform face recognition like using some live code. Okay, so face recognition, we have seen it in details. Like what is face recognition, the applications. We will directly move to how to perform face recognition in Python, and that is how to teach the computer to perform face detection. Face recognition, I mean to say. So here we will be seeing how we can do, how can you teach a computer to recognize a face, that means like how to detect first and then recognize. So here the first step is to locate and extract the faces, which is the face detection that we have seen in the previous section. So that means we, from the bigger image, we will be running our sliding window classifier, and which will say, okay, which window has face and which window doesn't have face, okay, which will return the faces. Okay, now the task is to recognize whose face is this. So let's just see how to do that. Okay, so what we have to do is we have to represent a face as features. So that means we will be computing encodings of a face. So we will be using an encoder decoder to compute these encodings. So basically this is encoder decoder is also a neural network based architecture, where what we do is we provide an input image to the encoder, and the decoder tries to reproduce the same image from the encoding that the generator generates. So the encoder's task is to identify a lower representation. So that means an encoding of the input image. The input image is very big. It has to return a smaller representation which can uniquely represent this input face. Okay, and we use a decoder to identify whether the encoding is good enough to reproduce the face from the encoding. So if the decoder can reproduce the face, the same face from the encoding, that means our encoder has generated a very good encoding. Okay, so to compute these features, we will throw away the decoder, and we will be using only this encoder to compute the encodings for all the different faces. Okay, so that means for different faces, the encoder should like generate different encoding. Okay, so, and if it's a similar looking face from different angle, the encoding has to be somewhat similar for same faces. So for example, this first face and the third face looks similar, and their encoding also looks something similar. Okay. So we will be using a pre-trained encoder model to compute the encoding for the faces, so that we don't have to worry about training an encoder, and we can get get access to a highly accurate face encoding, or the highly accurate encoder. So the third step in face recognition is to compare the face encodings of an unknown image with the known faces. So for this, what we have to do is we have to compute a database. Okay, so in the database, like what I have done is I have placed 3 images. You can place many. So for example, if you are setting up it for your home, so what you can do is you can compute images for images of all the people at your home from various angles, and you can create a database. Here I have created a small database for illustration purpose. So what we will be doing is for all the faces in the database, we will compute the encodings. Okay, so these are the encodings that I have computed. So these encodings are for illustration purpose. These are not the real encoding. Real encoding is somewhat larger in size. I think around 256 size vector. Like these are just for representation purpose. Then what we will be doing is for the test image, we will compute the encoding, and we will compute a distance of this test image encoding with all the encodings in our database. Okay, so what does it mean by the computing the distance? So it is step 4, where what we will be doing is we will compute Euclidean distance and apply a threshold. Okay, so Euclidean distance is the most commonly used distance function used in machine learning. If you people don't know, I have provided an equation for it. So what we are doing is basically it's a like distance between n-dimensional vectors. So let's say P and Q are those vectors in n-dimensional space. So to compute the distance, what we will be doing is we will first take a difference between each individual element. We will take the squared sum, and then we will take a square root. Okay, so basically this is the common, like this is the actual distance between the 2 vectors in an n-dimensional space. Okay, so this is the formula, and like what we will be doing is we will be using a distance rule. That means we will apply a threshold, and if the distance comes out to be less than 6, we will say that okay, it's a match. So that means the distance means how far these are. So if the distance is less than 0.6, it means these are not that far. If the distance is greater than 0.6, that means these are very far. These are highly different faces. So for this is our example from the previous slide. So we have computed the distance, and these are the distance that came out. So the first image, the distance of the test image with the first image is high, very high, 0.95. It is greater than 0.6. That means it can't be that. Second is 0.85. It can't also. It can also. It can't be the like matching face because it's greater than 0.6. The first and the third is like 0.39, which is less than 0.6. That means we can say that okay, these two faces are these encodings are very similar to each other. Okay, so that means we consider this is the face. That means these are the three faces. The first person I don't remember the name. Second is the Leonardo DiCaprio's. Third one is the George Clooney. So that means this test image belongs to George Clooney. Okay, so this was a few steps of face recognition. Now let's just see how to perform it in code. Okay. Sorry for keep on changing the screens. I think this is how we have to go. So let me just share it again. Okay. So I hope you can see my screen. Yes, I think you can see now. So let's just move away from the face detector. Let's just go to the face recognition. Okay, so we are at face recognition. So we will be using our face recognition package and matplotlib to perform some of the operations, and we will be using OpenCV to read and write images. So I think this is common what we have seen in the previous section as well. So what we will be doing is we will first create a database, okay, as we have seen in the slides. So I have read the same images. What is the face demo? The first person in the slides. This is the George Clooney, one image from George Clooney and one image from the Leonardo DiCaprio. In real world, you should carry multiple images of the same person so that you can have variations of the faces. Okay. Here, for relationship purposes, I have only taken one image. Okay, I have read the images and I have converted them from BGR to RGB. So now what we will be doing is we will the next step is to compute the encodings. So what we will be doing is let me just type it for you. Okay, so face recognition package provides this face encoding function, which we can use for all the faces. So this is our face demo image. Okay, and we have so basically these face encodings are also let's say if the image contains multiple faces, so this function also returns multiple encodings. So that's why we have used 0 here. We will only use the first face. Okay, so that means it's a list and we will be taking the first element of the list. Let's just store it in a variable. Okay, so we will do the same for George Clooney. Okay, so let me just face encodings and this is Clooney. Okay, 0. Okay, so the same we will be doing for Leonardo's image. Encoding. Okay, face recognition dot face encodings, and this is Leonardo, I think. Yes. Okay, so this is how we have computed the encoding for all the three faces, and then what we will do is we will create a database. That means I have just stored these encodings in a list. Okay, and I think this will work. Okay, so I think it is taking some time. Okay, it is done. Now what we will be doing is we will first load our unknown image. Let's just say maybe let's just not repeat from the slides. Let's just read some other image of Leonardo. Leonardo.jpg we read. Let's just say we will read Leonardo 2. Okay. So we will do the convert color, and then what we will be doing is we will be computing encoding for this unknown face image. We have not used 0 here because the test image can contain multiple faces, and we want to compute encodings for these multiple faces. Okay. So basically, like if the image contains multiple faces, we can recognize those multiple faces as well. Okay, so this is our input image. We have computed the encoding for this. This is Leonardo. So let's just see how to compute the distance first. So we'll be using SciPy to compute the Euclidean distance. So what we have to do is, for all the encodings in the known image, we will be running. So for example, there are multiple faces in the image. We will be running a for loop for it. Okay, so we will be computing distance with all the images in our database. So that means we are running a for loop for that. Okay, and then we will compute a like threshold for it. Okay, so this is the distance.Euclidean unknown face encoding, and that means we have computed the distance between the known and unknown face encodings, and we have appended that in a variable named results. And then we have applied a threshold operation here with a threshold of 0.6, and the threshold is less than if the distance is less than the threshold, this line will return true, otherwise it will return a false. True means the face is contained in the database, otherwise it is not contained. Okay, so so what I have done is, like, for each of position, if the 0th position is true, we will say that okay, it's a face demo image. If the first location is true, it will be George Clooney. If the second location is true, it will be Leonardo DiCaprio. Let's just run it and let's just see. Okay, so it says that found Leonardo DiCaprio in the photo. Okay, so this thing that I've showed here also works for images which contains multiple faces. So let me just try to run it. Okay, so this is an error. Okay, so this is the image which contains two faces, and I have running it, and it says that found Leonardo DiCaprio and the George Clooney. Okay, so that means this tutorial is also like this. The code that I have shown is works for multiple faces as well. Okay, so maybe let's just try to read something which is not contained in the database. So let's just read the woman's image. Okay, so this is the woman's image, and it says that okay, found unknown. Okay, so that means it is not available in our database. Okay, so that means we can train a face recognition model very accurately using Python. Okay, so this was for face recognition. Let me move to the slides again, and I can share the screen with you. Okay, so this is okay. So I hope you can see my screen. Okay, shit. Okay, so I think, yeah, now I have added it to the stream and you should be able to see it. Okay. Okay, so this was about face detection and face recognition. Now let's just see a few interesting applications. So for example, maybe applying makeup on the faces or doing some really cool operations on the face images. Okay, it's already 4 p.m. I will try to wrap it up as soon as possible. I think if you have any questions, please ask on the comments. I will take the questions just after the slides. Okay. So before performing any operation, let's just talk about facial landmarks. Okay, so which is so that means, let's just say the most commonly used face landmark model is 68-point face landmark model, where it will locate the landmarks of the face. So for example, eyes, nose, lips, chin structure. So this, okay. So I will show how to compute this using face recognition package, and we can basically we can locate different landmarks of the face, eyebrows, and this thing. So we can use this landmark model to apply makeup. So for example, we can apply lipstick on the faces. We can apply goggles. We can apply mask on the face. We can also replace the face. Okay, so these are the cool applications that we can do. I will be showing this in the code very soon. Okay, and like other than these cool applications, we can also use this face landmark model to improve the accuracy of our face recognition system. So what we can do is, let's say the face is slightly tilted towards left or right, or maybe in some other direction. So what we can do is we can rotate that face and we can align it with the template here that I have shown. Okay, so that means the face is looking towards front, then like the accuracy will be very high because we have access to the various landmarks of the face. So let's just see how to apply makeup on the faces. Okay, so I have to switch. I have to share the screen again. I'm sorry for it. I think I can share an entire screen. Okay, so I think you can see me. Okay, so this is our code. So let me just first tell you about how to compute the face landmarks. So basically, like I will show you that there, like this is the face landmarks, which returns the position of the chin, left eyebrow, right eyebrow, nose bridge, nose tip, left eye, right eye, top lip, bottom lip. Okay, so these are the things. So let's just see how to apply makeup. Okay, so maybe I will read Cloney, or let's just say read Leonardo this time. Okay, so Leonardo. Okay, so this is the image. Yeah, this is the image. Let's just compute the face landmarks. To compute the face landmarks, this face recognition package provides a method of face landmarks. Okay, and we'll provide the image. This is the image. Yes, this is the image. Okay, so so it will return face landmarks list. Okay, so if there are multiple images, there will be multiple landmarks for multiple faces. Okay, so what we'll be using is, we will be using M lines from matplotlib to plot lines on the faces, and polygon to plot polygons around like maybe lips and others like eyes, this kind of things. Okay, so what we will be doing is, we will be running a for loop for all the landmarks that I have told. So like if there are multiple faces, there could be multiple face landmarks. Okay, so what we will be doing is, for each face there are multiple landmarks, like it is stored in a dictionary. So like let's say if we want to access left eyebrow, we will be accessing it like this: face landmarks, left eyebrow. Okay, and like what we will be doing is, we will be plotting all of these points in the left eyebrow using M lines. We will be plotting a line 2D, and then we will be adding this to the axis handle. Adding this line to the axis handle. The same we will be doing it with the right eyebrow. Okay, and then we can also plot a polygon. Okay, so what we will be doing is, we will be using face landmarks top lip. I will plot a polygon and we will fill it with some color. Okay, edge color will be consider different color for the edge and for the like in between the polygon. Same with the bottom lip, and then we have added this patch to the axis. Okay, let us see. Okay, so this is the Leonardo. Let's see, right? So we have plotted the eyebrows and then we have also given some lipstick to it, and this is very accurate, right? So it is colliding with its lip edges. It's very good. I think let's just try a different image. This time maybe face demo. Let us try. Okay, face demo.png. Okay, so this is the image that we can try, and this is the face landmark we have computed, and then let's just see how the lipstick will look like. Okay, this is very good, right? So just see, right? So that means our landmarks are very accurate. So it is not colliding with the teeth, and that, like, so it is accurately filled the top lip and bottom lip. Okay, so maybe you can use this face recognition package to perform many much operations. So for example, you can also apply mask on the face. Okay, you can apply goggles. So because like you already have access to the eye orientation, and then using that you can apply goggles to the faces. Okay, so maybe you can try it on your own, and you can see a few interesting applications. So this is a, like, I think too much time. Maybe let me just finish up with the last like section, which is your take home exercise. So whatever we have learned in this face recognition tutorial, you can use this and you can create your own smart home surveillance camera. So basically, what you can do is you can use a Raspberry Pi and Pi camera as the hardware, and you can put it on at the entrance of your home. Okay, so for example, this is the Raspberry Pi, and this is a very small camera that is going that is placed on this yellow lid. Okay, and you can create a box for it, and you can create it like this. So basically, you can mount it anywhere at your home. Okay, and you just have to provide it a 5-volt power supply, and then it will like work like without any like input. Okay, so it can be a very good surveillance camera, IP camera, and you can create it. You can also start your own startup with it. Okay, so to set up the Raspberry Pi without any extra hardware like monitor and other stuff, you can use SSH, and this like link provides the details for it, like how to do it. So basically, you can access so basically Linux is running on this single board computer, Raspberry Pi, and you can so basically you can like set it up how to install face recognition and other stuff. For installing face recognition, you can follow this link from the providers of the face recognition. They have provided how to install it on the Raspberry Pi. Okay, you can use OpenCV to access the camera live. So here, like, we have only worked on the images, so you can also work on the live stream. Okay, so how to access the live stream from the camera on Raspberry Pi using OpenCV, you can follow this tutorial. Okay, and then you can use this lecture to perform face recognition. Okay, on the live stream, just detect the faces and then recognize whether those faces are contained in your database. Okay, and then see who is coming at your home. Okay, and okay, let's say if you are away from home, you can switch on this camera, and you can also like set up some push notification, so that if some unknown person enters your home, the system can notify you on mobile. So what you can do is you can send push notifications to your phone using Raspberry Pi. To do that, you can use this. So basically, this is a very good example to like see how we can send push notifications to a mobile phone from Raspberry Pi. Okay, so these are the like 6 easy steps to set up your own home surveillance camera, and it's a take home exercise for you. Please do it, and if you do it, maybe like we can provide you more tutorials, and maybe for recommender system, how you can make your own recommender system, how to do mask and no mask image classification, and there are many more examples that we can provide. Okay, so before proceeding, maybe I would like to tell about myself. I'm basically pursuing PhD at IIIT-Delhi. I work on computer vision and reinforcement learning. My work was on multi-camera target tracking. If you want to access my work profile, you can visit this webpage, and my details and my projects and if I have opened any code, all details are available on this webpage. Okay, so you can join our WhatsApp group, Think AI, if you want more such details. Maybe in place of that, you can join our Telegram group. Maybe let me just write it. I'm sorry for not providing it. Telegram channel. Okay, it's very easy to find as well. So it's t.me. It's Think AI. Okay, it's very easy. You can find it very easily. I think you can also apply like this. Okay, so this is what like you can follow this Telegram channel. It is it will be very good for you. And we are also on Quora. We are around 15,000 followers on Think AI, and like we are spreading free knowledge for AI and ML, like using these channels. Okay, so thank you for attending the tutorial. This is about myself. Let me just take a few questions. Let me just see the doubts. Okay, okay, there are many comments. Okay, hello sir, if provide code then only we will watch. If you provide code then only we will watch. I'm not sure. You earlier do not provide code. Sir, there is a little echo in the live stream. Okay, Muthu Kumar C, good morning. Okay, will you provide code? We can see if we need to provide code. I'm not sure. I think we did not set up any feedback form. If we set a feedback form, we can like provide the code if you people provide feedback. But let me just go with the genuine questions. Good afternoon. How to detect face in the image? I have showed in the tutorial how to do detect face and how to recognize faces in the image. Yeah. So Amruta and Purna, right? So I have like shown in the slides. I think section 3 and 4 are for face detection and face recognition. Okay, it was too fast. I'm sorry for that. Is the size of the input image fixed or varying? It can vary. I haven't fixed the size of the input image. The face recognition package automatically handles this. Okay, can I see the previous slide? Okay, I'm sorry, which slide you are talking about? Maybe you can, Sonali Sinha Roy, if you have any query, maybe you can email me or you can join our maybe WhatsApp group or Telegram group, and then you can ask questions there. You can ask questions to admin. Basically, you won't be able to like ping on the group, but we can like very good afternoon, useful information, not visible, not visible. Colab notebook is same as Jupyter notebook. Yes, it's kind of same, but the Colab it's running the same Python notebook but on the cloud. Okay, so that means the everything that is running is on the Google server, not on your local machine. In Jupyter notebook, it will run on your own machine. Okay, kindly show one more. Okay, I think I showed many examples. Code is not clearly visible. Zoom, edge, zoom. Can we extract values, key point from detect face frame? Okay, Fitos Kumar said that can we extract value, eyes, key point? I'm not sure what the question means. Can you please provide code after the session? We can see if we can provide. Okay, so maybe join our Think AI channel and subscribe our like what we say our YouTube channel. We can share the link for the code on our Think on our Telegram channel. Okay, just join our Telegram channel. Are the dimensions of the rectangle fixed? No. Pruna says that like no, this is not fixed. This depends on the size of the face in the image. Triplet loss function. Okay, I did not talk about FaceNet. Okay, I just talked about an application. Yes. Pruna says that please provide one more webinar exclusively dedicated to deep learning based face recognition. Yeah, we can do that. Just join our Telegram group. We are providing one session every week, and you can get like links for those if you are subscribing to our channels. Please send code. How many algorithms are available in machine learning? This is a general question. Please share the code, feedback link. Thank you. Please provide how many algorithms are available. Can we use webcam? Yes, you can use the webcam, but like the main thing is webcam is a little bulky, and PyCam is very easy to handle with the Raspberry Pi, and it's only designed for Raspberry Pi, so it's convenient to use. But you can use webcam; it's not a problem. I have used webcam with the Raspberry Pi; it's not a problem. So from where Rishi Mishra asked, from where can we learn these things? Join our WhatsApp group. and like subscribe to our channel. We are providing like these tutorials regularly every week, and you can join those. How long it will take time to learn Python? So maybe just like send me an email or a message on WhatsApp. I can share some resources. I think Python doesn't. If you are good at programming, Python will not take you will not take more than a few hours. I learned it in like few hours, and then like I kept on learning new things when I started doing some practical stuff. Okay, how to connect camera with this code? So, do you mean, Amruta asks how to connect camera with this code? Do you mean how to do it in the live stream? If you mean live stream, that then we can easily do it. So just use OpenCV. OpenCV like provides like you to access the camera live, and then you can access this live stream frame by frame, and then you can use the code that I have showed in the tutorial. Yeah, I think I have answered your question. Uh, yeah, I think if there are more questions, please feel free to ask. And subscribe our YouTube channel. Join our Think AI. Like see if there are more sessions, we will let you know on like on these channels, and then we'll keep sending you the information. Will it work on Windows? Yes, it will work on Windows. It works everywhere if you have access to Python. Okay, so let me. Okay, so if there are any more questions, please feel free to ask. We will like wrap up very soon. Okay, so rather than Colab, can I use PyCharm? Yes, you can use PyCharm. You can use Jupyter Notebook. You can use like scripts, and you can run it on in command line. Everything works. It doesn't hurt. How will I get access to Python? I'm not sure what does it mean. Okay. Can you use Java for this? Basically, you can use face recognition in Java, but this face recognition package is only available for Python. Okay, so thank you all. So can we make our own algorithm? Yes, you can make it. Like you just have to uh, basically last week we have provided how you can make your own neural network algorithm. I think you missed it. Maybe you can see our channel, and there is a there is a video on getting started with neural networks. We will be like providing next week. We will be providing the tutorial on image recognition with neural networks. Okay, so this is what we had. Okay, so maybe I just want to stop sharing. Okay, so thank you all for attending. I think we can stop this session. So if any of you have question, please feel free to ask. Otherwise, like we are ending this live session. Okay, thank you. I hope there are no questions. If you have any question, please ping us on email or on phone. We will try to answer your questions. Thank you. Join our Telegram channel and subscribe our YouTube channel. Thank you.